So we're going to do another classic Algebra 1 problem. We're going to be given a line and a point not on the line, and we are being asked to find a perpendicular line through the given point. So again, I want to start out with looking at a geometric representation of what this description is telling us, and then we will run through the algebra for this problem. Alright, so the line has a y-intercept at -5, so we come down 1, 2, 3, 4, 5. So we're going to have the y-intercept here at -5. And then again we have a slope of -4, and we need that to be a rise over run. So we have 4, and we need this to be a fraction, and so we just take the whole number and we put it over 1. If you want to check this in your calculator, you will find that 4 divided by 1 is still 4. We put the negative here. I like to keep it in my numerator for these problems. And so we have a -4 over 1, and so we're going to come down 4 and then go over 1, and that is going to give us our next point, and then we draw in our line. Up here we're going to put in the 0.35, so 1, 2, 3, and then come up 5. We're going to have a point up here, and so we're going to have a line that comes through here as our perpendicular. To just kind of sketch in the line that we're looking for, I'm going to use my library card here as a straight edge. And so we have approximately this line here that we are looking for. So I have a y-intercept right here for my new line. 1, 2, 3, 4. I'm going to estimate that the new y-intercept that I'm looking for is going to be at 4. And so when we do this calculation where we do the algebra, that is kind of a checkpoint for me to see that I'm on the right track. So let's go ahead and take a look at this. To find a perpendicular, I have some steps here that I want to kind of use to guide me. And I have 3 steps. I want to identify my original slope. I'm then going to find the reciprocal of that slope, and then I'm going to switch signs. So I had already found my original slope was -4 over 1. And then step 2, I'm going to find its reciprocal. And then I am going to switch signs on that. So the slope of my new line that I'm looking for is going to have a slope of 1 over 4. So this is my rise of 1 and my run of 4. And I also have to have it run through this point. So we're going to set up a way to do that. We're going to look at the slope-intercept form for a line, and then we're going to plug in what we know. The y is going to come from here, And so we have an x and a y value, so 5 is the y, and I'm going to plug that in down here. The slope here is this new slope that I found down here, so that is 1/4. The x is going to come from this point again, and this is an implied multiplication, and so I'm not going to know what my b value is here, and that's what I'm going to solve for. It's my only unknown. And so I have 3 times 1/4 is going to give me 3/4. And so we'll clean this up a little bit. And now, since I have the b being attached to this rational number by addition, I'm going to subtract that out. And I have to do it on both sides because that keeps me equal and balanced here. So 5 minus 3/4 is going to be 4 1/4. That's going to be my b value. And so now I need to reassemble this as the equation for my perpendicular line, and I'm going to use this b value for that and the slope that I used up here. The x and the y for my new equation is going to be variables. This is my dependent variable, my slope that I had calculated over here, my independent variable, and my y-intercept. And if we recall, my estimated y-intercept when I had graphed this thing was at +4. My actual calculated y-intercept is 4 1/4, so that's pretty close. And I'm going to say that this is our final answer. This line is perpendicular to the original given line that we had up here, and it runs through this point 3,5. Now, one thing we can do to check to make sure that this does indeed run through the point is we could substitute that point into here and see if that point does in fact make this a true statement. So let's do that as a way of checking. So we're going to check the point 3,5. So this is one way you as a student can check your work to make sure that you're on the right track, and you don't have to rely on an answer key or asking others for help on this. So we're going to substitute this in here. Again, this is the x and the y value. We're going to substitute it in for the x and the y. So 5 equals 1/4 times 3 plus 4 1/4. Oh, that's a 4. All right, so clean this up a little bit. Okay, so 3/4 plus 1/4 is going to be 1 whole. 1 whole plus 4 is 5. So I have 5 equals 5. And so yes, this is true. So this point is in fact on this line. Now, just so you know that this works, let's go back to our graph and pick a line that, or a point that we know is obviously not on this perpendicular. Let's pick the point 1, 1. So down here is the point 1, 1. It is nowhere close to being on this line. So this is a point 1, 1. If we try the same substitution in here, we should not get a true statement here. So let's do this just so you know that this process will work. So if in fact we had made a mistake, and perhaps we suggested that this point was on this line, and we now try to verify it, we're going to see that this is a false statement. So I put in x and y. So I have 1 equals 1/4 times 1 plus 4 1/4. 1 times 1/4 is 1/4. So I end up with 1 equals 1/4 plus 4 and 1/4. 1/4 plus 1/4 is 1/2. I end up with 1 equals 4 1/2. This is a false statement. This tells us that this point is not on this line. And so when we check the point that they give us in the line that we found, we find that it is a true statement. If we had found something that was incorrect and we go in to check it, we get something that is false. 1 is not equal to 4 1/2. This is false, so we know there's a problem. So here's a way to solve the problem algebraically up here. This is our process. These were the steps that I used over here to find my slope. This is a geometric representation of the problem. And then I have a system for checking it and what it looks like if we have done it correctly. And I've also showed the checking process with an obviously incorrect part of the problem here, and we get a false statement. So a lot of information here. So hopefully this is a good review for you in Cheerful Calculations.